This section is about differentiation and integration of exponential functions that have bases other than e. Definition of exponential function with a base. A to the x is e to the natural log of a times x, where a is positive real number, and a cannot be 1 and x is any real number. Number 1, a to the 0 is 1. Number 2, a to the u times a to the v is a to the u plus v. Number 3, a to the u over a to the v is a to the u minus v. And number 4, a to the u to the power v is a to the power u times v. Derivative of exponential function with base saying that a be a positive real number is not equal to 1 and u be a differentiable function of x. Number 1, d over dx of a to the x is natural log of a times a to the x. And the derivative of a to the u is where u is a function of x is equal to natural log of a times a to the u du over dx. Example 1, find the derivative of y is equal to 10 to the minus 3x. So let's write down y is equal to 10 to the minus 3x. So we differentiate with respect to x. So y becomes y prime, and this becomes d over dx of 10 to the minus 3x. Now we use the formula d over dx of a to the u is equal to natural log of a to the u du over dx with a is equal to 10. So we write natural log of a is 10. So we write 10 to the minus 3x, and then write d over dx of u, and u is what? Minus 3x. So we simplify natural log of 10 to the minus 3x, derivative of minus 3x is minus 3. Now we move the minus 3 out, so the final answer is negative 3 natural log of 10 times 10 to the minus 3x. Okay, so we find the derivative of y equals to x times 8 to the power 2x. So now it's x is the algebraic function and a to the 2x is exponential function. So we're going to use the product rule. So let's y is x times a to the 2x, y becomes d over dx, and this would be d over dx of x times a to the power 2x. Now the product rule says that you first function x and then multiply the derivative of the second function a to the 2x plus second function a to the 2x times the derivative of the first function x. So the derivative of a to the 2x is, using this formula, that will be natural log of a, and a is 8, and 8 times 2x, and times d over dx of u, and u is what? 2x, plus 8 times 2x, and d over dx of x is 1. Now we simplify. The x is natural log of 8, a to the power 2x. The derivative of 2x is 2, and a to the 2x times 1 is a to the 2x. It looks like both terms have a to the 2x, so we can factor a to the 2x. So you're left with 2 times x, natural log of 8 plus 1. Example 3, we're going to find the derivative of y is equal to 6 to the 3x over x. Now y is equal to 6 to the 3x over x is a quotient. So x is a algebraic function, 6 to 3x is exponential function. So we differentiate with respect to x. So y becomes y prime, and we can write d over dx of 6 to the 3x over x. Now we apply the quotient rule. The quotient rule says the square denominator, which is x squared, and then write the denominator x, multiply the derivative of the numerator, which is 6 to the 3x, and then minus the numerator 6 to the 3x, multiply d over dx of the denominator. So now we simplify. So we write the derivative of 6 to 3x using this formula. So we write natural log of the base times 6 to the 3x times the derivative of 3x is 3 minus 6 to the 3x times the derivative of x is just 1 over x squared. And now it looks like we can factor out, we can simplify, you can move around 3, we can make it 3x, natural log of x, 6 to 3x minus 6 to 3x. 6 to 3x can be factored out, and you're left with 6 3x times 3x times natural log of 6 minus 1 over x squared. Find the derivative of y is equal to minus 3x squared over 5 to the x. So again, it's a quotient, so we apply the quotient. So it become y prime, and we square the 5x, and we write the 5x and multiply the derivative of the numerator negative 3x squared, and then subtract, and then write the numerator minus 3x squared and multiply by the derivative of the denominator 5 to the x. Okay, so now we write 5x, 5 to the x, and the derivative of minus 3x squared is simply minus 3 times 2 is minus 6x, and then minus minus becomes 3x squared, and the derivative of 5 to the x is just natural log of 5 times 5 to the x times the derivative of x is 1. So that's it. Now let's simplify. We can, so we have 5 to the x we can factor out, and you're left with minus 6x plus 3x squared natural log of y. Now on the bottom, 5 to the x squared, we can write 5 to the x times 5 to the x. Now we can cancel 1 5 to the x, remove 5x. So the final answer is negative 6x plus 3x squared natural log of 5 over 5 to the x. Definition of logarithm function to base a. If a is the positive real number and not equal to 1, and x is any positive real number, then the logarithmic function to the base a is denoted by log of x base a, and is defined as log of x base a is equal to 1 over natural log of a times natural log of x. Number 1, log of 1 base a is 0. Log of uv base a is log of u base a plus log of v base a. Log of u over v base a is log of u base a minus log of v base a. Number 4, log of u to the n base a is n times log of u base a. Number 5, log of a to the u base a is u because the bases are the same. A to the log of u base a is equal to u. So this is 5 and 6, these are called inverse properties of logarithms. Derivatives of logarithmic function with a base a. Let a be a positive number not equal to 1 and u be a differentiable function of x. Number 1, the derivative log of x base is simply 1 over natural log of a times x. And the derivative log of u base a is 1 over natural log of a times u over times du over dx. Find the derivative of the function. So the f of x is log of cube root of 5x plus 3 base a. So let's write in. F of x is log of cube root of 5x plus 3 base 4. And the cube root means the 5x squared plus 3 is a power of 1/3. So we can simplify using log of un, u to the n base a is n times log of u base a. So we can take the 1/3 power out and multiply log of 4 of 5x plus 3. Now we differentiate with respect to x. So f of x becomes f prime x, and this becomes 1/3 d over dx of log of 5x plus 3 base 4. Now this is the base c, and the formula for we apply this formula. d over dx of log of u base a is 1 over natural log of this base times u and d over dx. So here a is 4. So we can write 1/3. So that would be natural log of a, and a is 4. So we write natural log of 4. And now this is u. So we write 5x squared plus 3, and then multiply the derivative of u, which is 5x squared plus 3. So now we just copy down 1/3 and copy this from 1 over natural log of 4 times 5x plus 3. Now the derivative of 5x squared is 10x, and the derivative of 3 is simply what? 0, so we just 10x. So now we simplify it, so 1 times 10x will be 10x over 3 times 5x squared plus 3 times natural log of 4. So we put the natural log at the end, and that's the answer to the example 5. Example 6, finding an equation of tangent line. Find an equation of tangent line to the graph of the function at the given point. So this is the function y equals to 6 to the x minus 3, and the point is 3, 1. So now we start with the y is equal to 6 to the x minus 3. So we differentiate using the d over dx of a to the u, which is natural log of a times a to the u d over dx of u. So y becomes y prime, and we have a d over dx of 6 to the x minus 3. So using this formula, so we write the natural log of a, but a is 6, so they become natural log of 6. And then we write the exponential, which is 6 to the x minus 3, and multiply the derivative of exponent x minus 3. So we copy down natural log of 6 to the x minus 3, and write the derivative of x, which is 1, and the derivative of 3 is 0. So we simplify, and you get natural log of 6 times 6 to the x minus 3. Now we substitute x equal to 3 because we wanted the slope. So this becomes, we call this m, y prime becomes m slope, natural log of 6 to the 3 minus 3. Now we simplify. So we simplify, we get natural log of 6 to 0, and 6 to 0 is 1. So we slope is natural log of 6. Now we write the equation of line, and the formula is y minus y1 equals m times x minus x1. So we substitute m is equal to natural log of 6, and x1 is 3, and y1 is 1. So this equation becomes y minus 1 equal to natural log of 6 times x minus 3. We distribute natural log of 6, so it becomes x times natural log of 6. And we also move the minus 1 to the right, plus 1. And this natural log of 6 times 3 minus become minus 3 natural log of 6. And but there's a point slope form. So if we move the y to the right, so it becomes x the natural log of 6 minus y plus 1 minus 3 times natural log of 6 equal to 0. Example number 7. Use the logarithmic differentiation to find dy over dx. So here we have a y is equal to 1 minus x to the power 2 over x. Now here the base is variable and exponent is also variable. So they are like a very special exponential. So you say, when the exponential function has both bases and exponent variable, there is no other way to differentiate such as exponential function without taking logarithm. So we start with this form y equals to 1 minus x to the power 2 over x. Now we take the natural log of each side. So it becomes natural log of y, natural log of 1 minus x to the power 2 over x. And now we apply this, simplify using this formula, power rule. Log of u to the n base is n times log of u base a. So this becomes 2 over x times natural log of 1 minus x. Now it's like a product. So you're going to apply the product rule. So we have a natural, so differentiate both sides. So natural log of y, the derivative is 1 of y dy over dx. And this is the denominator x, so we square that one. Write the x and factor out to is a constant, coefficient. D over dx or natural log of 1 minus x minus natural log of 1 minus x times d over dx of dx. And now basically we simplify. So we have 1 over y times y prime equal to 2 times, and that would be x derivative of natural log of 1 over x, so this becomes x over 1 minus x. And the derivative of x is 1, so this just becomes minus natural log of 1 minus x. So we just rewrite, so we factor out x squared, we write 2 over x squared times bracket x over 1 minus x minus natural log of 1 minus x, and bracket close. Now we multiply both sides by y to simplify, because we're going to get y prime. So it becomes y times 1 over y times y prime is y times 2 over x squared times bracket x over 1 minus x minus natural log of 1 minus x. So these y's cancel, so you're left with y prime. And y is originally is 1 minus x to the 2 over x, so we replace that one here. So we have 2 over x here, bracket x over 1 minus x minus natural log of 1 minus x. So I think that's basically it. We just rewrite and we do put it in the front. So you have 2 times 1 minus x to the 2 over x squared, bracket x over 1 minus x and minus natural log of 1 minus